Hello everyone, myself Dr. P. Pramod Kumar, Associate Professor in the Department of Mechanical Engineering, MLR Institute of Technology. Welcome you all to the video lecture course on engineering mechanics. Today in this video, we will try to solve a problem on equilibrium of forces by using Lami's equation. The problem is a ball of weight 120 newtons rests in a right angled groove as shown in figure. The sides of the groove are inclined at an angle 30 degrees and 60 degrees to the horizontal. If all the surfaces are smooth, then determine the reactions RA and RC at contact points. So this is the given figure. A weight or a ball of 120 newtons is resting in a right angled groove. The angle between the two walls is 90 degrees. The walls are in such a way that one wall is making 30 degrees to the horizontal and another wall is making 60 degrees to the horizontal, so that the angle between the walls is 90 degrees. That's why it is called right angled groove. The weight is given 120 newtons. Now we need to find the reaction at contact point A, that is RA, and another reaction from the wall, that is RC, at contact point C. See the free body diagram for this given problem. The ball is resting like this and there is weight acting through the center of the body and reaction is perpendicular to the contact surface. Here the contact surface is making 30 degrees to the horizontal, and to that plane reaction at C is perpendicular, and RA, another reaction at contact point A, this is also perpendicular to the contact surface. Now D, E and F, these are the points. If you extend the lines of action of forces downwards, D, E and F, or D and F, especially D and F, are the intersection points of lines of contacts of forces with horizontal. Right. Now look at the force diagram. The force diagram, weight always acts vertically downwards and the reaction RA is making an angle of theta 1 with the horizontal, and RC is making an angle of theta 2 to the horizontal. Unless we find the theta 1 and theta 2 values, we cannot proceed to solve the problem. Either of the methods, Lami's equation or resolution, both requires the angles. Now let us find the angle made by RA with respect to horizontal and angle made by reaction RC with respect to horizontal by using the given diagram. Look at the free body diagram. Here RC is perpendicular to the contact surface. This is the contact surface. Now here we got a right angle triangle DEC. DEC is the right angle triangle. This angle is 90 degrees as RC is perpendicular to the contact surface. This is the contact surface and this is line of action of RC. These two are mutually perpendicular. Here the angle is given, the plane or wall is making an angle of 30 degrees. We know that the total angle in a triangle is 180 degrees. This is 90. So the remaining angle, or the angle made by RC with respect to horizontal, is given as 60 degrees. Similarly, look at the AEF right angle triangle for the RA. To find the direction of RA, look at the right angle triangle AEF. Here this is 90 degrees because this is the line of action of RA and this is plane or wall, inclined wall. So line of action of RA will be always, the reaction will be always perpendicular to the contact surface. This is the contact surface. So the angle is 90 degrees here and this plane is making an angle of 60 degrees. This wall is making an angle of 60 degrees. Now, the remaining angle is 30 degrees. So, here the angle made by RC with respect to horizontal, that is theta 2, is 60 degrees. The angle made by RA, that is theta 1, is 30 degrees. After finding the required directions of unknown reactions, next proceed to solve the problem. So 60 degrees is the angle made by RC and 30 degrees is the angle made by RA with respect to horizontal. Now we got the angles made by both the reactions RA and RC. Weight always acts vertically downwards. RA is at an angle of 30 degrees to the horizontal. RC is at an angle of 60 degrees to the horizontal. From this point, we have two methods for solution. One, we can apply Lami's theorem. Lami's theorem is applicable only when three forces are acting and the three forces are concurrent. All the forces are meeting at one point and the body is under equilibrium. We can apply Lami's theorem, or we can go with the resolution of forces. In the resolution of forces, sigma h is equal to 0, sum of all horizontal forces equal to 0. Here we have two components, RA cos 30, RC cos 60. These two are the horizontal components of the reactions. So two forces are there and they are in opposite direction. So sigma h equal to 0 is one equation. Another equation is sigma v equal to 0. We have downward 120 newtons weight and it is balanced by sum of two vertical components of RA and RC. So by using equilibrium equations or by using Lami's equation, we can solve the problem. Here in this video, I am applying Lami's equation to find the unknown reactions. The Lami's equation is given by P by sin alpha is equal to Q by sin beta is equal to R by sin gamma, where P, Q, R are the forces and alpha, beta, gamma are the angles in the triangle. Now substitute the values in the Lami's equation. W divided by, weight W 120 newtons divided by sin alpha, sin of angle between other two forces. If we consider 120 newtons, the angle between other two forces, other two means RA and RC. Angle between RA and RC is 90 degrees. 90 degrees. See here, 180 minus 90. So sin 90. Next, RA divided by angle between other two forces. RA divided by angle between other two forces. Here, other two forces are 120 and RC. Angle between these two is 90 plus 60. 90 plus 60. Sin 90 plus 60. RA divided by sin 90 plus 60. Finally, RC divided by angle between RA and weight. The angle between RA and weight is vertically downwards. So up to horizontal it is 90. From the horizontal line, RA is making an angle of 30 degrees. So the total is 90 plus 30. Now the equation is reduced to 120 divided by sin 90 is equal to RA divided by sin 150 is equal to RC divided by sin 120. Now we equate first two terms to find RA and any two terms. After that, any two terms to find RC. Let us take first two terms. RA divided by sin 150 equal to 120 by sin 90. RA is equal to 120 by sin 90 into sin 150. The value of RA is now 60 newtons. 60 newtons. Similarly, RC divided by sin 120 equal to 120 by sin 90. Now RC is equal to 120 divided by sin 90 into sine 120. The value of RC is 103.9 newtons. In this way, we can solve equilibrium problems by using Lami's equation. Thank you.